Whew. Man, is it hot today here in Texas. You know, there's very few things that a lot of us take for granted and at the same time appreciate more than the comfort that air conditioning and heating provides. But the question is, if you build an AirCrete structure, is it truly an efficient structure? What does it actually take to heat and cool your AirCrete house? You know, these are questions that are asked, and many people say it in this way: will it actually keep me comfortable in my climate? I live in Maine, I live in Canada, I live in the Sahara Desert, for example. And to answer that question, today we're going to show you how to do a heat load calculation. A heat load calculation, well, let's call it a heat load measurement instead of a calculation, even though there's calculations involved. I'm going to show you how to measure the actual heat usage of your house and answer the question, how do I know how much air conditioning it takes to heat and cool a house when you design one from AirCrete? So let's get started. All right, so as it just happens, I have 30 years of experience in the HVAC and construction industry. So let's show you how to do this test with some simple tools. First, you'll need a good quality meter with a temperature range on it that uses a K-type thermocouple. That way you get very accurate temperature readings. Then you're going to need a humidity meter that will measure the wet bulb temperature. For this particular test, if it doesn't measure wet bulb, then it's not going to be as useful to you without doing some conversions from relative humidity. I'll put a link below in the description to these two tools so that you can check them out if you would like. All right, so the first thing you're going to do is either heat or cool your structure to the maximum temperature difference that you expect to experience in your climate. Now, you convert a cheap window unit, and we'll put a link here that you can click on to check out an article where we converted a cheap window unit over to a quiet packaged air conditioner. Or you can use a space heater. Heat or cool your house to that maximum temperature difference from the outside temperature. You know, if it's 100 outside, then in Texas I would recommend cooling it down to 70 or heating it to 170. But once you've achieved this temperature, let it stay there for 1 hour. That way the walls, everything in the house becomes climatized and more in a normal state of operation. The next thing you're going to do then is to go in, you know, make a little air movement, fan with something, make a little air movement, and wait till you get a good stable reading and record your wet bulb temperature inside of the house. Write it down, put it in your phone. Next, you're going to go to beside the door, and you're going to tape this thermocouple to the wall so that it sticks out away from the wall about 6 inches. And then you're going to move this cord under the door, over the door, beside the door, but you're going to close the door on this, and you're going to measure the temperature from outside. Give the house about 20 minutes to stabilize. And after 20 minutes, record once again your indoor temperature and set your phone timer. You can use a stopwatch app, a clock, just make sure it's accurate. Start your timer, set it for an hour, and then just walk away. Returning in 1 hour, immediately record the indoor temperature inside your structure. What we need to know is what is the difference between the starting temperature and the end temperature. And if you're heating, subtract the end temperature from the beginning. If you're cooling, then do it the other way around. If you come out with a minus sign on the calculator, just ignore it. But you need to know the number of degrees that the air temperature changed inside the house over an hour. Write that value down.
Let's face it, having an alternative building constructed for you can cost more than conventional construction, up to $250 per square feet. Building a 450 square foot house can cost as much as $90,000 to have a company build. Build it yourself and save $80,000. Do you want to build alternative homes for others as a professional? You could profit up to $70,000. The material of the building is immaterial. Slapping mud on a wall, ramming earth, stuffing a bag with dirt, or AirCrete. These skills can be learned in a day or two. The real skill begins when you are ready to make your tiny house functional. Electric, solar, air conditioning, plumbing, flooring, or alternative waste water management. This is where many people fail to finish their homes or pay large sums of money to hire skilled labor. Others fail in the planning or logistics stages. They buy the wrong land, underestimate cost, do not know how to hire and manage unskilled labor, or fail to connect infrastructure. This is why we now offer the Terlingua Alternative Building School. Beginner or experienced builder, come learn how to build a tiny house from scratch in far less time and expense than traditional paths of learning. You can learn and experience every skill you need. Now you can proceed with confidence to build the house and life of your dreams.
The next thing we're going to need is some data off the internet. So let's begin by calculating the volume of your structure. If you're building a dome, then calculate the volume of a sphere and divide it in two. And that will give you a good enough approximation of the volume of your sphere. And of course, there's plenty of calculators online for any shape you could imagine. Just punch it in Google. If you're doing a cylinder or a rectangle house, but find the volume of your house in cubic feet. Write that number down, and then also do a conversion and write that number down in the number of cubic meters inside of your house. And then it's time to go online also to get just a few numbers. Search and find out how many pounds of air are in a cubic foot. A quick search and we see that it's 0.0807 pounds of air per cubic foot. Multiply that number by the volume or total cubic foot of your house and write this number down. That will be the pounds of air inside of your house. Next, we're going to do another Google search and we're going to take a look and see how many BTUs does it take to change 1 pound of air by 1 degree. A quick look online and we see that it takes 0.24 BTUs per degree per pound of air. So write 0.24 down as the BTUs per degree per pound of air. Now we're going to figure out exactly what amount of BTU, British thermal units, it took to change the temperature of the air inside of your house. So take the weight per cubic foot of air, multiply that by the cubic feet inside your house and write that number down. This is the total pounds of air inside of your house. And then take this number and multiply it by 0.24, which is the BTU change per pound of air, and then multiply that by the difference between your starting and ending temperature during your test. This will tell you the total amount of BTUs over an hour that has passed through your structure to heat the air up. But that's not the whole story. Moisture, water that is in the air has an amazing ability to store a lot of heat. So we're going to need to know how much water was in your air, and that's the reason we took the wet bulb temperature. So let's go over to the NOAA.gov site and let's have a look at a little calculator that they have so graciously provided us. And we discover that if we punch in the dry air temperature inside our structure at the beginning of the test, we punch in our wet bulb temperature, and you may have to convert over to centigrade if you took this in Fahrenheit, and it will automatically calculate stuff for you. You can ignore the dew point, but what we're interested in is the absolute humidity in grams per cubic meter. And this number, in the case of this example, 8.11 grams per cubic meter is the number you need to know. Now multiply this times the total cubic meters inside of your house, and this gives you the total grams of water in the air for your structure. But we're not done there. We need another data point. So let's find out with a quick look online. We'll see that it takes 1 BTU to change 1 pound of water by 1 degree. Another quick search tells us that there's 453.592 grams per pound. So we need to know the BTU value per gram. So what we're going to do then is divide 1 by 453.592. Take this value and multiply it by the total grams of water that are in the air of your structure, and then multiply that by your temperature difference. And what this gives you is the total BTUs that were held in the water and how much energy it took to change that. So add this value to the amount of BTUs it took to change the air, and this is the total BTUs that it took to change the temperature inside of your structure by the number of degrees over 1 hour. And so this is the BTU hour rating, which just happens to be the value of air conditioners. It's the industry standard for rating air conditioning and even heating. So with that number, you'll be able to then size your air conditioner for your house, for your climate. Now, having done the math, how does AirCrete compare to conventional structures? Well, using typical heat load calculations and doing the comparison with the actual measured results, we find out that in comparison to normal construction, AirCrete has a slightly lower insulating value than a timber frame wall with fiberglass in it as far as R value and heat transfer is concerned. So if you were, for example, doing a standard heat load calculation, you would simply multiply that value by 1.0625, or 6.25% is added to the heat load calculation to give you the value for an AirCrete structure. Very useful if you want to do a conventional heat load calculation. But of course, the way we showed you here is very accurate for your climate and very accurate for your actual structure, because it's going to be taking into account the heat and gain through windows and doors and cracks. So I actually would encourage you to use the calculated method to determine the actual needed value to heat and cool your home so that you can remain comfortable in any climate. And so these are the kinds of things that we teach at the Trilingua School of Alternative Building, and our workshop material comes with a pre-training and post-training course that will train you in all of these skills. This year is going to be the first occurrence of the Trilingua AirCrete Rapid Build Workshop has now become the first class of the Trilingua Alternative Building School, and the price is never going to be this low again. So if this kind of thing interests you, if you want to learn how to do every skill involved in building a house, including how to hire and manage other people to build it for you, to save a great deal of money or to make great deals of money by building houses for other people, then click the link below in the description to find out more.